All right, guys, let's go ahead and get going. I think I gave enough time for people to jump in here. If you can hear me and see me, give me a thumbs up. Just make sure you're with me. All right, very good. So let's look at 7.2 homework. Any questions over 7.2 homework, guys? Any questions over the 7.2 homework? Okay, Abby says 2. All right, 2 and 4. All right. So an airplane takes off. Let me get this camera just right. Sorry about that. An airplane takes off 200 yards in front of a 60-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? Assume the airplane flies in a straight line and the angle of elevation remains constant with the airplane flying over the building. Okay, so I have a 60-foot tall building here. So 60-foot tall building. Oh, it's 60. I have this airplane that's about to take off. Okay. And what it's asking. Okay, I'm sorry. I'm on number 3. Let me just draw it up here. Sorry. So I got a building down here, and that's 60 feet. Okay. The airplane over here is 200 yards away from the building. And what it's asking here is this right here. At what angle? What is this angle? What does this angle need to be in order for the plane to keep from hitting this? Okay. Now, first thing we need to discuss is to always make sure you get the same units. So 200 yards is equal to 600 feet. Okay? So just make sure we know that. There's 3 feet in a yard, so 200 times 3 is 600 yards. This is 60 feet, and it's wanting to know this angle. Now, because it's going to the top of this building, this 60-foot building, we know that it just has to be greater than whatever that angle is right here. Okay? So, based on these numbers, I need to find that angle. Well, anytime you're finding an angle, you're going to use the inverse. Okay? Use trigonometry inverse. So, what is this over this to that angle? That's opposite over adjacent. What is opposite over adjacent? That should be tangent. So, the inverse tangent of 60 over 600. And that would give us 60 divided by 600. Make sure you're in degree mode. 5.71. I'm going to say approximately 5.7 degrees. I looked up another way. You remember how I told you about the form? I hadn't written something like that in a little bit. So another way you could write this is this, guys. You could say tangent of x degrees is equal to 60 over 100. And then on both sides, you just do the inverse of tangent. Like that. That cancels there, and then x degrees is what we're doing there, and that gives you 5.7. So that's another way to kind of show that within that. All right. 5.7 degrees. Does that make sense? Abby, anybody else who had that question? Okay, cool. Yeah, no worries. All right, and then hey, make sure you are in make sure you're in degrees. Make sure your mode, make sure it's in degrees for starters, not radian. Make sure it's in degrees. Second quick, and then second, the inverse tangent of 60 divided by 600. Should be 5.7. Lucy, if that doesn't work, reset your calculator by hitting second plus 712. Second plus, and then just reset 1, 2. And now I'll reset everything for you. And then that should help you out if that didn't. Cool. All right. Now let's look at 4. So 4 says, standing on a cliff 380 degrees above the sea, Pat sees an approaching ship and measures its angle of depression, obtaining 9 degrees. How far from shore is the ship? Now Pat sights a second ship beyond the first. The angle of depression of the second ship is 5 degrees. How far apart are the two ships? Okay, so we have a cliff. Okay, here's my cliff. And Pat sees an approaching ship. So I'm assuming down here is a little bit of water. Okay. Pat sees an approaching ship. And its angle of depression is 9 degrees. So from here to here. Now look, angle of depression, it wouldn't be this right here. Remember, there has to be 2 horizontal lines. So the angle of depression would look like this. This triangle right here. And it's 9 degrees there. Okay? And the cliff is 380 degrees. Or excuse me, 380 feet. So the first question it asks is how far from shore is the ship? So what's this distance right here? And again, if that's 380, then this over here is 380, right? And it's asking for this distance right here. Same thing. So let's first start with that one. So what is this to this 9 degrees? What is this to that 9 degrees there? That is opposite over adjacent. Opposite over adjacent is tangent. So I would say the tangent of 9 degrees is equal to opposite over adjacent, 380 over x. Okay? Multiply both sides by x. That cancels. I get x tangent of 9 degrees is equal to 380. Then just divide tangent 9 on both sides. And I get x is equal to 380 divided by tangent of 9 degrees. I got a big number. I don't know if that's right. 2399.2 round to the nearest 10. Yeah, cool. 2399.2. And that is in meters. So that's how far the first ship. The first ship is 2399.2 meters from the shore. Okay? The first ship is 2,399.2 meters from the shore. And the answers are on the back, so that's what 4, but I didn't give part B answer. Sorry, I was just probably going through there writing those answers down. All right. Now it says, now Pat sights a second ship beyond the first. And the angle of depression for the second one is 5 degrees. So still it's 5 degrees now is the angle of depression. That's still 380. And it's wanting to know how far the ships are apart. So we already know this distance right here. We already know from here to here. Now we just need to get the total distance from here all the way down here and then subtract the 2. Okay? So we're basically doing the same type problem here, but instead of 9 degrees, we're using 5 degrees. So tangent 5 degrees is equal to 380 over x, which we should know come out to be x equals 380 over tangent of 5 degrees. 380 divided by tangent of 5 degrees is 4,343.4. And then when we subtract those two, minus 2399.2, the distance, the ships are, I got 1944.2 meters apart. Can someone confirm that? That those answers are right? Okay. That's what Mary got. Okay? So, you may be saying, man, that's a long way apart, okay, for such a change of degree from going from 9 degrees to 5 degrees, okay? So think about like this person on the cliff looking. They're looking down. I'm kind of facing this way. They're looking down at 9 degrees, and they're looking up at, or down at 9 degrees, and then they go up a little bit more to go to 5 degrees looking down. Obviously, looking straight ahead would be 0, okay? So looking down a little bit would be looking at 9 degrees, or like 5 degrees first, then 9 degrees. And you would think, man, like that's not that much of a difference, but the distance is very, very long. To show you an example, okay? Suppose this was an airplane, okay? Suppose this right here, this pin. I wish I had an airplane. Actually, let me go get an airplane. Here's the airplane. Kind of perfect airplane for this too. Okay. So, say you were leaving Los Angeles. Okay? Say you were leaving Los Angeles and you were flying to New York. All right? So, you're flying from Los Angeles, Los Angeles to New York. All right? Now, let's say that you were flying right here. All right? Let's say you were flying at 0 degrees. Now, obviously, we know that, New York is a little bit more north of Los Angeles, I would assume. Not, my geography is not the greatest. But the cool thing here is the math, all right? If you were to tilt the nose of this plane by 3.5 degrees, 3.5 degrees, that's 3.5 degrees would be about 86 inches, okay? So if you were just to point it like, for instance, again, I know this is going to be kind of hard to show you, but if this is 0, if you just went down just a hair, 3.5 degrees south, so going from here to here, again, I know it's kind of hard to show, so like from here to like there, just barely moving it a little bit. You don't fly into New York City, but you fly into Washington, D.C. That just goes to show you how much a little bit of a degree can change a trajectory. Okay? So if you're flying at LA, if you're flying from LAX going to New York, if you tilt the nose of that plane by 3.5 degrees down, you're going to end up in Washington, D.C. So you would obviously think, man, it'd be much more than that. Like it would take more degrees than that to land so far south from there. But I guess that's the cool thing about degrees in math. So a little bit of real world connection today within this. Let me look at a map real quick. Yeah, this will be a good one. Maybe not. So right here, here's LA, okay? Up here's New York. A 3.5 degree change in this right here takes you from landing right here to landing right down here. So you can kind of tell, you can kind of see the difference. And you may be saying, why in the world are you doing this? Why are you showing this to us, Mr. Alpok? I'm just trying to show you the impact of that little change of degree. Okay. So that is that. Now, if I was to, there's a book out that I've read. It's called Atomic Habits, and that's where I actually found out about the whole, 3.5 degrees difference will land you in Washington D.C. opposed to New York City flying from L.A. But the book is a phenomenal book about the small things and how if we can improve those, if we can really, really get the small things right and the small habits down, that how successful we will be later on. I was hoping to be able to read a book with you all this spring, and I was actually planning on it because I got all my books back from my AP Calculus class, but that may just have to wait till next year to pre-calculus. And I've actually ordered some books. So for next year, I know I'm going to read some with my AP Calculus. You all may have to wait to AP Calculus, or I may be able to get some more books for us to kind of read through as a class in pre-calculus. So we will kind of see within all that. But hopefully we can get more books. I would try to do it like where like, hey, you go order the book, but I try to do that with my AP Calculus, and only 2 kids got the next book. So I've learned that if we're going to do a book club and kids are going to read, I actually have to order the books, give them to you, let you borrow them, and then take them back in. But no worries. So just kind of that. Any other questions on 7.2? One. From the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far away is the object from the base of the cliff? So again, we got a cliff here. So here's our cliff. The cliff is 40 meters high. And the angle of depression to the object that's level with the base. Here's the base. So there's an object down here, level with the base, right? And it's saying the angle of depression to this object is 34 degrees. So we had to make our triangle like this. This angle right here is 34 degrees. That's 40. So this is 40. And it's wanting to know what that distance right there is. What is x here? Okay. So that's opposite over adjacent. So we would just say tangent of 34 degrees is equal to 40 over x. And with this, we end up with x is equal to 40 over tangent of 34 degrees once you multiply everything out. And then you get x is equal to 40 divided by tangent of 34. 59.3. So 59.3. And that's meters. And that should be about right because this is a little bit bigger than this, right? And this cliff, the hypotenuse would be the longest. Any other questions on the homework? Making sense? Do you want to see? Are you good on number 3, Christina? I think that I agree with you. I agree with you on that, Lucy. Sometimes it's hard to kind of set these up. I agree with that. Kind of hard to like know exactly what you're looking at. And when we're in class, I do like a little walk around the room, kind of like with these things, because this takes a lot of practice. It takes a lot of practice to kind of get this down. So, but your main thing is knowing what angle of depression and angle of elevation is. Once you know that, then it's just a trig function. So establishing what that is, how to draw it. It can be challenging, but just know that there's always, for instance, like on this one right here, like let's say that, the issue that I've always seen kids run into is they draw that cliff 40 meters high. Then they want to do that right there and claim that as the angle of depression, but that's not the angle of depression. It just, remember, angle of depression is always, but it's always below the 2 horizontal lines, and unfortunately that would be under it. That would be like under another line. Okay, so always know this, that any triangle can be drawn another way. Okay, all triangles can be drawn a second way, and it'd be the same measurement. So this right here can be the same thing as this right here. Well, it's actually a good question, Christina. So, what if you did draw? Let me go to the back. what if you did draw this angle, like what if you did draw this triangle like this right here, right? And you're saying like if these are your horizontal lines, right? So we know above our horizontal line would be an elevation. This right here would be angle of elevation, right? Because it's above it. Okay. But in terms of elevation and depression, this angle right here, yeah, you really wouldn't call it anything, if that makes sense. Okay. Now, here's a unique thing. You can change, again, you can always change the way triangles look. Okay. And you technically could change from horizontal lines to vertical lines. So there's a couple different things you could do. So if only either angle, gosh, you can't type. So on the right, if it only either the angle directly under the first horizontal line to the left, or the one, I guess it keeps disappearing, or the one in between the lines on the bottom. Correct. So your horizontal lines, okay, it's only, again, if we were to draw something like this right here, this is my angle of elevation here. This is my angle of depression. And then again, I could kind of form the right triangles with two different things. Does that make sense? The angle of depression is always this angle. And we're only working in horizontal. We're only working on a horizontal plane. We're not working on a vertical plane. We're working on a horizontal plane. Two lines. So you really don't ever, this is a right angle. That's a right angle. So you don't even have to worry about that angle there and that angle there. You wouldn't have to worry about them. Yeah, just the inside. And remember from the notes, they're opposite, or excuse me, they're, what is that word? What word did I use on the notes? Alternate. They're alternate interior angles. These angles are. They're alternate interior angles. These two angles are the same. Well, this is depression. This is angle of elevation. So these two technically are the same. So that poses this question. I'm kind of glad we're getting into this. So you know the whole 40 meters high cliff? So a 40-meter high cliff, right? That's what it was. Had an angle of depression of 34 degrees. Right? And it wanted to know how far, it wanted to know x, right? That's what we found, right? Opposite over adjacent. Yeah, okay. How else could I draw that triangle, though? And still get the right answer? Could I draw that triangle like this? Say that's 40, right? Or 40 meters, sorry. But this wouldn't be 34. This would be 34, right? And then we would be looking at that right there. Would that work? Is that the same thing as this right here? To determine x? Well, let's see. Opposite sine of 34 degrees. What do we get over here? Sine of 34 degrees is equal to x over 40. Multiply both sides by 40. What is 40 sine of 34? 22. So would that work? No. That would not work. Oh, is it tangent? 40 tangent of 34 degrees. And that won't work either. Oh, no. Sorry. What am I saying? 40 times tangent of 34 degrees. Yeah, and that's 26. So what I would, and this is just knowing your angle of elevation versus angle of depression here. Just trying to mess around with it to see. If that's 34 degrees, that's 56 degrees. If I brought that in, adding the 34 would make that a true 90. And 56 here, right? And we're just experimenting, people. Just kind of experimenting with stuff. So no one freak out. You don't have to do this. We're just trying to mess around with this to see. Okay. Hold on. It took me a second to look at it. And the reason it doesn't work out and it's been a second since I looked at stuff like this. But I think the reason it doesn't work out is based on these degrees and based on the information we're given, this wouldn't be a square. No, but it'd still be a rectangle, so those still should match up. Interesting question about if we flipped it over and then just used what we know about angles to calculate this, if we could work on it like this. Does anybody have a thought on that or input? Or see a mistake that I'm doing? And what we're trying to do, and this is, I'm telling you, this is the kind of cool part, because everything should work out. So we use this triangle right here to find our answer. 34 degrees here, 40 meters here. We know that's 90, and we need to find that. So what we used was tangent of 34 degrees is equal to opposite over x. Multiply both sides by x. We get x is equal to 40 divided by tangent 34. And we get x is equal to, that was the 40 divided by tangent 34. And we get 59.3 degrees. Let's see what you said, Maddie. When you did tangent on the bottom, it should have been 40 over x. Oh. So if we use this triangle, so maybe I did make a mistake, which is 40, that's 56, and that's x. No, sorry, that's 34. 4 degrees. So Maddie's saying that it should be tangent of 34 degrees equals opposite 40 over x. Yeah, there you go. Sorry. Man, I was tripping there for a minute. I'm thinking, man, what in the world's going on? Am I not doing this math right? So there you go. So, and again, this is taking it to a whole nother level, guys. But what we're trying to show you, or what I was attempting to try to show you here if I do my math right, and that should be, I'll just cross that out. What I'm trying to show you that is if you knew that this was 34, you can draw the triangle the other way, but you just got to know where to place 34 is. So, you know, if you said your cliff was on this side, or if you said your cliff was on this side, either one, you just have, they both work. And what I'm trying to show you is that these two triangles, they are equal to each other. They're the same thing. Christina, does that, I know you didn't really ask that question. I really just kind of went into it just talking. But does that make a little bit of sense to you? Yeah, I don't know. I don't know what you all did in geometry. So same. I mean, yeah, same thing in terms of, you know, similar triangles, but obviously different. You know, angles are a little bit different. It's just been turned, but and you can imagine that being rotated. You know, so just another way to look at it in that horizontal thing. Yeah, that is true. And that's the key is seeing, you know, seeing those two things and then how to draw it. I agree with that. And again, I think that's the hardest part. Once you draw it, I think you guys can handle the trigonometry part of it, knowing opposite, adjacent, all that type stuff. But where to put the angles, where to put that. So hopefully, again, you don't have to do this, guys. This is just, I'm trying to explain this another way that you could draw it another way. But I don't know. To me, this drawing it this way would be kind of a little bit more confusing to you. But it is another way to draw it. And keep in mind that if we, you know, drew this right here with those horizontal lines, again, look, 34 would be right there. 34 would be under it, the angle of depression, right? And then that's an alternate interior angle. They're the same angle right there. Okay. And then, of course, these two add up to be, you know, that right angle, 90. All right. Very good. Now let's move to 7.3 notes. Let's move to 7.3 notes. Once you got that out, give me a thumbs up that you guys are good and you got it, and we should all be good. All right, I see like 3 of you here. Okay, there's Bernice. There's Lucy. Okay, cool. All right, jumping into 7.3. Okay, thank you, Caitlin. So, looking at this, we are we're going to continue in our whole degrees and talk and stuff like that. But one of the first things we're going to hit on is you having the ability to understand how to do radians and degrees. Okay, how to go from radians and how to go to degrees. All right. So when you're looking at a radian, okay, I think you guys know what a degree is. It's the measure of an angle. So a degree a degree, sorry about that, let me try to fix that. Degree is a measure of an angle. Okay? A radian is a pure measure based on the radius of a circle. Based on radius. And I'll just say based on radius. Okay? So, guys, this is just degree in radian is just like inches and feet. There is 12 inches in 1 foot, right? There is 3 feet in 1 yard, right? So how we can go from yards to feet, from feet to inches, right? And this is obviously the standard conversion chart or our standard system. Obviously, we could go to metric system as well. But something else that in the world of triangles and trigonometry, we go from degrees to radians. And 1 degree, okay, or excuse me, 1 radian is equal to, I had it on my calculator. Let me see. $57.2958 degrees. Okay? So, radians are just it's just a measure of a degree. Okay? So if something was 57 degrees, you'd say, well, that's about 1 radian. Okay? Now, that may not mean much to you, but what you need to understand is just the simple fact that a radian is about 57 degrees. So 2 radians, yeah, kind of, yeah. Yeah, it's the first part's pretty simple and easy. So 2 radians is equal to so 2 radians, sorry about that, would be equal to about 114.5916 degrees. 3 radian would be equal to 171.8874. Okay? Now, notice this. This is getting really, really close to a number that is kind of familiar in the angles world, and that's 180, which is a vertical line, or excuse me, a horizontal line. So a horizontal line, or what we call a vertical angle, is 180 degrees. So what number around 3 would you say would be equal to 180 degrees? What number, what famous number around 3 radians would be equal to 180 degrees? Pi. Yeah, very good. So pi radian is equal to 180 degrees. Okay? Now again, if I was to show you, I told you that 1 radian was 57, right? So 1 radian is 57.9. So 57, or let me say this, second pi, and just say times 57.2958. Now we know that number is a little bit more than that in the degrees, but that should give us 180 degrees. So if I ever ask you, what is the degree of pi radians, you would tell me 180 degrees. Can somebody tell me what's the radian of 90 degrees? Trick question here. What is the radians of 90 degree? A 90 degree angle is what is how many radians? It's not really a trick question. It's just, do you know math question. Anybody? Half a pi? Okay, yeah. Half a pi or pi over 2. Okay, 1/2 times pi, what Maddie said, or pi over 2, same thing. So pi over 2. So say second pi divided by 2. That's kind of awkward, right? I'd have to multiply that then. So times 57.958. And there's the 90. Sorry, I didn't multiply that. So pi over 2 times the 1 radian. 1 radian is 57 point, is the 90 degrees. All right, last question here. How many radians is in a full circle? How many radians is in a full circle? How many radians is in a full circle? Okay, what is 6.283? Yeah, there you go, Caitlin. Good. 2 pi. So 2 pi radian is equal to 360 degrees. Okay? 2 pi radian is equal to 360. Pi over 2 radian is equal to 90 degrees. All right? So just trying to give you some, and what you're going to have to do often sometimes is convert degrees to radians. All right. Now those are all pretty simple. We can just say pi. We can say pi over 2. We can say 2 pi. We never want it as a decimal though. We always want it as a fraction. Okay. So in order to convert, degrees to radians, you're going to need this formula. You just need to take whatever you have, okay, and multiply it. Take your degree. So I'm going to say take your a degree and multiply it by pi over 180 degrees. Okay? So whatever you have when you're given a degree like this, okay, multiply it times pi over 180 degrees. Now, here's an easy way to always remember this, guys. An easy way to forever remember this right here. Always remember, if you're going from degree to radian, you want to cancel your degrees because you don't want degree symbols anymore. And the only way to cancel your degree symbols is to literally have the degrees in the denominator, and obviously this would be the numerator. Okay, so let's jump to number 1. 660 degrees into radians. So I'm only going to do this, times pi over 180. And I could put that over 1 there, just for fun with the whole fun with, a fraction times a fraction. Then watch this. My degrees cancel. And then I just multiply straight across. Or I could cross simplify first. Whatever you want to do. 660 pi over 180. 660 divided by 180 is, as a fraction, that would be 11 pi over 3. And that's what that is in radians. And again, I'm fine. Obviously, I can't control whether you use a calculator on your test now or not. So, might as well use it now. Sorry, yeah, that's what I'm showing you, Abby. So, just say, so again, your degrees cancel, then multiply 660 pi over 180, then just say 660 divided by 180, and that gives me 3.66, which is 3 2/3 or 11/3 if you convert that to a fraction. Does that make sense, Abby? Okay, cool. All right, let's jump to the next one, 150. So we want to say 150 over 1 times pi over 180. Your degrees cancel. Okay, Christina? So anytime I want to go from degree to radians, I multiply my whatever degree I have times pi over 180. Okay? I cancel my degrees. And then what I did here was I just multiplied 660 times pi. I got 660 pi. 1 times 180 is 180. Then I just simplified this right here. So I said 660 divided by 180 and got that, which is 3 2/3. But if I just use the fraction button on my calculator just by hitting math, which is below alpha, and hit enter for fraction, and then it gives me 11/3. And then pi is always going to be there for radians. Okay? Are you good with that, Christina? Okay. So come over here. We take whatever degrees we have. Is there ever a time we will have to have pi in the denominator, and is it allowed to stay there? I don't know if I fully understand your question, Maddie, but most of the time, technically, I mean, this right here can be written like this: 11 pi over 3, 11 over 3 pi, 11 over 3, and pi's on the side. It can be rewritten any way you want. So technically speaking here, yeah, it can be anywhere. Most of the time, it's going to be, you're going to see it kind of like on the side with me, probably. You're probably going to see it on the side. I don't know. You may see it at the top. Who knows? But all three of these are the same. All three of these are equal. Hold on. Let me restate that. I'm treating that like a negative. I shouldn't treat that like a negative. It can be all three of them except the bottom one, I think. Except it can't be in the bottom. Sorry. No. I am right. Sorry. Man, I'm second guessing myself. All three of these work. It can go in any one of them. No, I am right. Holy smokes. I'm off my game today. It's been a minute since I taught. Okay, so sorry about that. Here you go, Maddie. Let's clear that confusion. So 11 pi over 3 is 11.59. 11 divided by 3 pi is 1.16. I didn't think that was looking right. So it can't go in the denominator, but it can go on the side like that. Okay, 11.59. So that's the one that it doesn't work in. I'm sorry, I was thinking of negatives, and a negative can go in the numerator, denominator, or on the outside. Sorry, I had a brain lapse there for a minute. So, but to answer your question, as far as the denominator, no, it shouldn't be in the denominator unless it would be there. Now, you're about to see some, when we go from radians to degrees, you're going to see, obviously, something else kind of take place here, okay? When you go from radians to degrees, the pi's are going to cancel, but that's when you'll see in the denominator, but they'll cancel down there. So, but hope I didn't confuse you on that. But yeah, it can't go in the denominator. It can only go in the numerator and on the side. The denominator would be a totally different answer. After I wrote it, I'm like, that looks right. Well, no, it doesn't look right. All right, so continuing on over here. So our degrees cancel, and we just say this, guys. Again, now I can cross simplify 150 and 180 right now, okay? But since you have your calculators, I would just say 150 pi, multiply numerators, multiply denominators over 180. And then I'd come over here with a calculator, and I would say 150 divided by 180. We know 30 would go into both of those, and then just hit math, which is right here, math, and then go to fraction, 5/6. So 5 pi over 6 or 5/6 pi. You're probably going to see me write like that. But what can't happen, what I accidentally just said to Maddie, was this right here. That cannot happen. It stays in the numerator on the outside. You can't go math and then hit enter. That won't put it into a fraction for you. If that's the case, Christina, here's what you're going to have to do. So, and it's not hard. It's just a little bit of math. You can do it on your You can still do it on your calculator. Just do a little bit more math. So here's what you know. 10 will go into that 15 times. 10 will go into that 15 times, and it'll go into that 18 times. So now I'm at 15 pi over 18. 3 will go into that 5 times. It'll go into that 6 times. So now I'm at 5 pi over 6. Now, of course, you could do that math. I'm doing it in my head, but you could do it on the calculator as well, if you don't have that to fraction button. Does that make sense, Christina? Oh, okay. Yeah. I got you. I see what you're saying. Yeah. So, like, do like I did and say 150 divided by 180. Don't leave pi on the side. Okay? Let's go to number 3, 30 degrees. Give me a thumbs up if you're kind of understanding this, you're seeing it. Again, it's just a simple multiplication step. Cool. Good, Lucy, Bernice, Maddie, good. Okay, so right here, you're just going to multiply this times pi over 180. Again, to go from degrees to radians, you just need to know to do this right here. Pi over 180 degrees. Your degrees cancel, and I'm left with this, guys. 30 pi divided by 180. Just like multiplying fractions in 6th grade. Now, I can type this into my calculator, or I can know that 30 will go into itself once, and it will go into 18 6 times. So then this is just equal to pi over 6. Okay? Jumping over here to 125 degrees times pi over 180 degrees. That cancels with that. The degrees cancel. I got 125 pi over 180. Again, if I didn't have a calculator, I'm fine with you going and type that in your calculator. If I didn't have one, I know that 5 will go into 125 25 times. Yeah. And that'd be 25, and 5 will go into 180 36 times. Right? Just want to make sure my math's right. Yeah, 36 times. And then what will go into 25 and 36? Nothing will. So that's 25 pi over 36. Okay. 45 degrees. Now, again, guys, we can do that as pi over 180. But what else would 45 degrees be? How, if we know that pi, okay, listen. If we know that pi is 180 degrees, then what's 45 degrees? Well, it would just be pi over 4. Right? Because there's 4 45s. Very good, Maddie. There's 4 45s in 180 degrees. So half of 80 degrees is 90 degrees, and that's pi over 2. So then take off another one, that'd be pi over 4. Now, just in case you're not seeing that, no worries. Just say pi over 180. The degrees cancel. I get 45 pi over 180. 45 will go into both of those. 45 will go into itself once. It'll go into 180 4 times. Pi over 4. And again, If you had to use your calculator, I'm fine with that. Just say 45 divided by 180, and you're going to get 0.25, which is 1/4 or 1/4 pi. Going to 120. Just say over 1 times pi over 180. Cancel, cancel. I got 120 pi over 180. Well, I know 20 goes into both of those. 20 goes into that 6. 20 will go into that 7, 8, 9. 9. And then I got 6 pi over 9. And 3 will go into that twice. It'll go into that 3 times. So 2 pi over 3. Or 2/3 pi. Either one will work. All right, give me a thumbs up. We feeling good? We all right with that? Just as simple, just multiplying times pi over 180. Good Maddie, good Lucy, good Bernice, good Christina. Good Caitlin. Good Abby. All right, let's jump down here now. Let's go the other way, okay? So, just kind of recapping, going from radian to degree, use pi over 180. Dang, sorry, Bobby. Dude, I'm all over the bus train today. All right, so in order to go from degree to radian, multiply it times pi over 180. But to go from radian to degree, do just the opposite. Do the reciprocal. 180 degrees over pi. Because you want your pi's to cancel. You need to know these two things today. Make sure you know this, guys. Degree to radian, radian to degree. And again, always ask yourself, what do I want to cancel? If you're going to degree to radian, what you want to cancel is the degrees. So the degree has to be in the denominator. You're going from radian to degree. What do you want to cancel? The pi's. So you put the pi in the bottom. So jumping down here to number 7, convert each radian measure into degrees. So 2 pi over 3. So just say times 180 degrees over pi. So watch this. Pi's cancel. What's 2 times 180? Well, double 180 is 360 degrees. Divided by 3, and that's going to take me to 120 degrees. Okay? Jumping over here to number 8. 7 pi over 6 times 180 degrees over pi. Automatically, my pi's cancel. 7 times 180, I don't have a clue what it is. It's 1,260. I divide that by 6. I get 210 degrees. $19. or excuse me, 9. 180 degrees over pi. Your pi's cancel. 13 times 180. I don't have a clue what it is. 2340 divided by that 6 equals 390 degrees. Give me a thumbs up. Is this making sense, guys? Or I guess ladies, Dom, I don't know if you're on here. Okay. There we go, Dom. All right. Over here, times 180 over pi. Pi's cancel. 180, just using my calculator here, times 4, 720 degrees divided by 3 should be 240. All right, pi over 2. What's pi over 2? Someone type pi over 2 in the chat box. What is that in degrees? If pi is 180 degrees, if pi is equal to 180 degree radians, then what is pi over 2 then? Should be 90 degrees times 180 degree over pi. Pi's cancel. 180 divided by 2 is equal to 90 degrees. Last one. 180 degrees over pi. Pi's cancel. 9 times 180. 1620 divided by 4. 405. Give me a thumbs up. You guys good there? Cool, Lucy. Okay. Now, what we want to do here is kind of start connecting everything that we've done thus far. All right. So we've talked about these angles. We've talked about right triangles. We've talked about all this stuff. Now let's look at it in terms of, these different type angles. All right. So here's what I kind of need you to know about just some, and this is just kind of some general information about angles in an XY plane. All right. So let's say you are given a y-axis and an x-axis. So x, y-axis, and we know that's the origin there. We know 0. Okay? Here's what I need you to know. I really need you to know basically two terms. All right? I need you to know the initial side. Okay? And that's going to be a line that does this right here. Okay? This is what we refer to as the initial side. Okay? All angles, when in a XY plane, guys, all angles start on the initial side, which is the positive x-axis. Okay? Now, you are then going to be given some other angle. Maybe it goes out like this. It could be a little bit sooner or a little bit closer. Not sure. Okay? This is what we refer to as the terminal side. And of course, this right here would be theta, or our angle. Okay? So when dealing with angles in an XY plane, we just have some vocabulary here. We have an initial side, we have a terminal side, and we have the angle. Okay. And that's, you just really need to know that vocabulary there in order to kind of understand these instructions here. So it says, use the given point on the terminal side, use the given point here on the terminal side. The terminal side's this, the terminal side's the one that goes out. This right here would be my initial side. Of angle theta to find the value of the trigonometry function indicated. Okay? So, I'm going to use this right here. Use this point right here, which is 4 comma 2 radical 5, in order to find sine of theta right here. What is theta? Theta is this angle right here, guys. Okay? So, here's what I'm going to do, guys. I am literally, even though this is an XY plane, here's what I'm going to do. In order to find that angle right there, I'm going to draw a triangle. So here's that. There's the up. That's the side there. Now, what that triangle looks like is this, guys. Looks like that. It has, look, that's the x coordinate, that's the y coordinate. So its y coordinate is 2 radical 5, and its x coordinate is 4. And it wants us to find sine of this angle right here. Find sine of that right there. Okay? So, of course, what we'll need to do, guys, is we will need to say, well, Sohcahtoa. Sohcahtoa. Sine here is opposite over hypotenuse, so it's opposite of this over hypotenuse. Now we don't have hypotenuse, so we need to go find it using a squared Pythagorean theorem. A squared plus b squared equals c squared. So we have 4 squared plus 2 radical 5 squared equals c squared. 4 squared is 16 plus this. Remember, you have to raise each one of these to the square. So that would be 4 2 squared is 4 times the square root of 5 times the square root of 5 would just simply be 5 equals c squared. So then that's 16 plus 20 equals c squared, which is 36 equals c squared, which is c equals 6. Okay? So then we say, all right, opposite over hypotenuse is 6 sine theta is equal to 6 over 2 radical 5. So this is just like what we were doing, guys, earlier, like I think on our first lesson, 7.1, but now we're just pulling everything from an XY chart, XY plane. I cannot leave this as my final answer because it has radical 5 in it, and that just will not work. So I need to multiply top and bottom times radical 5. Okay? So if I multiply, so I need to say, I don't have to multiply everything by, I don't have to multiply top and bottom by 2 radical 5. I just got to multiply it times radical 5. So the top, I get 6 radical 5 over 2. And then this radical 5 times radical 5 is just 5. And then that goes to 6 radical 5 over 10, which 2 goes into both of that. 2 will go into that 3 times, and we'll go into that 5 times. No, it's not the inverse. It's not asking for the actual angle. It's just asking for that based on the triangle. Hold on. I have a discrepancy here with the answer key. The answer key is saying something else. I don't know why. Oh gosh, I'm telling you, thank you, Maddie. If you weren't here, I would lose myself. Sorry, guys. Anytime y'all want to step up and say something. Oh yeah, sorry, I saw where you said that. Yeah. So I accidentally did hypotenuse over that, and I was thinking, man, something's looking weird here. This is not right. It should be sine equals 2 radical 5 opposite over hypotenuse. Like that. 2 goes into itself once, it goes into that 3 times. So our answer here is sine of theta is equal to radical 5 over 3. So it's, sorry about that, Maddie. I now saw your message. Sine theta is equal to radical 5 over 3. Opposite over hypotenuse. And it's not looking for the angle, though. It's just looking for it based on what the triangle is of it, the trig function. Sorry about all that work. I'm doing more than I have to. All right. Jumping over here to number 14. Same thing here. It says find sine theta of this right here. So guys, only thing we need to do is just drop this down, make a triangle. I'm going to bring the triangle over to the side. I think you can see it a little bit better. Now, anytime you have an angle like this and your triangle, again, there's a couple different ways we could look at this. We could go that way and then go down, okay? And then we would just be looking at that triangle. But you can really just kind of extend this on through and just think about theta being that angle right there. it's the same way as if you look at the triangle the other way. Kind of going back to what we talked about earlier. You can look at it the other way and stop there, or you can make it go this way, just extend your angle a little bit more. Okay? So if we have this right here, now notice this is our x, that's our y. So our x is negative radical 19, and our y is 9. And it's wanting the sine, okay, of this right here. So in order to do that, we need to find sine is Sohcahtoa. So opposite over adjacent, or hypotenuse, excuse me. So it's right here. So we need to do a squared plus b squared equals c squared. So that's 9 squared plus negative radical 19 squared equals c squared. So that's 81. I'll explain here in a second. 81 plus 19 equals c squared, which is 100 equals c squared. Square root of both sides, c equals 10. So that's 10 there. Okay? So then here, its sine is just opposite over hypotenuse. So sine theta is equal to 9 over 10. Okay. So then, Max said, how are we supposed to know which angle they want? Okay. And here's the thing. Whatever numbers you use for it, okay, it's always going to be this kind of this inside angle right here. So notice right here, with this being negative 19, that means the point's there, and then positive 9's up there. Okay. So the angle, okay, would just be this inside angle, as Ike said, just extend that angle on out, since we made this right here the base of the triangle. I know that sounds extremely confusing, but you'll always just extend it out. And it will always be looking for that angle right there. Well, let me rephrase that. It's not looking for an angle at all. It's not looking for an angle at all. It's using your trig functions of the triangle. But what you use as your angle is going to be whatever that is on the inside here. And we'll see some more examples down here. Okay? All right, jumping down here to number 15. Just got 4 more problems left. Hang on, guys. So, cosine theta. So, again, I'm going to make this triangle right here the triangle, right? All right, so I'm going to redraw it over here. I have 7 is the y coordinate, negative radical 15 is the x coordinate. And then theta will, of course, just be this right here. It just extended on through. So that's theta. Theta's right here. Sohcahtoa, adjacent over hypotenuse. Adjacent is negative, sorry about that. Adjacent is negative radical 15 over hypotenuse is what we don't know. So let's do a squared plus b squared equals c squared. A squared plus b squared equals c squared. That's 7 squared plus radical 15 equals c squared. 49 plus 15 equals c squared. So that's 64 equals c squared. C is equal to 8. So in this case, adjacent over hypotenuse, cosine theta, is equal to negative radical 15 over 8. Okay? Give me a thumbs up if that's making sense to you. Good, Maddie. Good, Caitlin. Okay? So again, just what we were doing the other day, it gives us to it on a plane now instead of just a triangle. So we got a few more. So let's see if we can get better at it. So, looking at number 16, again, it wants cosine, Sohcahtoa. So we draw a line down to this and goes here. So this is theta, and I have negative 4, and I have 3 here. So I redraw my triangle. I have 3, and I have negative 4. That's 3 squared plus negative 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. So then c is equal to 5. We're finding our angles right here of the triangle. So we're finding cosine, which is adjacent over hypotenuse, negative 4/5. Okay. Now, if you were to draw your triangle the other way, which is completely fine, okay? If you were to draw your angle like this, or your triangle like this, and say that's 3 and that's negative 4, Keep in mind that this theta right here, it would not be there, guys. It would be alternate interior. So it would be up here. Okay? So then that, and again, that would be 5. So it would be adjacent over hypotenuse. Okay? So it would not be this angle, this little small angle right here. It would be this big angle up here. All right? Just in case you were to draw it the other way. All right? $17. And again, we could do that with all of these, okay? But you just got to keep in mind the angle you'd be looking for would be the top. It'd be the alternate interior of what we're doing. It wouldn't be this angle right here, okay? It would be this. It would be the whole big angle. All right? So numbers tangent. Sohcahtoa is opposite over adjacent. So if I have this right here, if I have this triangle, here's theta right here because it's going up, okay? This would be 6, that would be 8. Opposite over adjacent would be 8 over 6 or 4 over 3. Again, if I took that triangle there and said 6 and 8, and that was my angle. Okay. Lastly, coming over here, I would draw my triangle right here, go over. That's -6 and -8. So I'd have a triangle looking something like this, -6 and -8. Now again, my theta angle is going to be right here on this one. Okay, these are a little bit easier to tell. When it's in quadrant 1 and 3, it's a little bit easier to tell where your angle is. But when it's in quadrant 2, just keep in mind, extend it all the way through. And if it was in quadrant 4, extend it all the way through and just use that as your angle. Okay? It's a little tricky. So here, I need to do opposite over adjacent, tangent. So that's tangent theta is opposite, -8 over -6, which comes out to be 4 over 3 as well. Questions? Questions on that, guys? Any questions at all? And this right here is to really introduce us to the unit circle. So at the heart of trigonometry is what we call the unit circle, and that's next lesson, and that's what we'll start with, okay? If you guys don't have any more questions, thank you so much for being here with me today. Thank you so much for being, did we do this for 14 and 15? I don't know. I'm not sure what you're saying, Lucy. Did I do this for 14 and 15? Hey, I'm going to be here for a little bit, so Lucy, I'll stay around to answer your question. But you guys are free to go. Thanks for being here with us today. You guys have a good day. Stick around for any questions. Thanks, Tom. Thanks, man. See you all. On the homework? Yeah, you guys should be fine. 14 we did sine theta, 9/10, right? 15 we did cosine theta, right? Is that what you're talking about? I'm sorry. Okay, cool. Very good. Good day. Good day, good day.